often do we look up to admire the night sky, but have no idea what we're looking at? It's easy to forget that those twinkly stars are suns surrounded by planets. Our sun is just one of 100 billion stars in our Milky Way galaxy, which is one of around 100 billion galaxies in the universe that is visible to us. This year, hopefully, a new telescope will be launched into space to allow us to see further than we've ever seen before.
We want to understand who we are, where we came from, and our place in the universe, tiny as it may be.
Garth Illingworth is a distinguished Professor Emeritus of Astronomy and Astrophysics at the University of California. You've called space telescopes time machines. Why is that?
Telescopes are really time machines in a way because of the way light takes so much time to travel in the universe. The universe is huge, and we think of light as traveling instantaneously on Earth. But in fact, the light that we see from the sun actually left 8 minutes ago from our planets as we look at the probes which go past Jupiter and Saturn. That's more than an hour for that light to reach us, the signals to reach us from those planets. As we go out, the nearest star, the light takes 4 years. From the center of our galaxy, the light actually takes something like 26,000 years to reach us. So for the nearest galaxy, the Andromeda Galaxy, a large galaxy like our own, the light left 2.5 million years ago. The universe itself is 13.7, 13.8 billion years old.
But how is it that light can travel over 13 billion years and yet it hasn't disappeared, it hasn't faded?
It's got incredibly faint. So that's why we put big telescopes in space and huge telescopes on the ground. It's billions of times fainter than we can see with our eyes. And so we really need Hubble and, of course, the upcoming James Webb Space Telescope to explore that regime in time, back when the very first stars and galaxies were forming.
The James Webb Space Telescope, or James Webb to its friends, is a $10 billion international program led by NASA with the European and Canadian space agencies. It's named after US government official James E. Webb, who ran NASA's fledgling agency and set in place the Apollo moon program in the 1960s. Professor Illingworth led the small group that developed the next generation space telescope concept that became James Webb.
The director of Space Telescope Science Institute in the 1980s was Riccardo Giacconi, who subsequently won a Nobel Prize, and I was his deputy director. And Riccardo came in one day and said to me, "You need to start thinking about the next telescope." And I said, "But we haven't even launched Hubble yet, and we're up to our eyeballs trying to get Hubble to fly and to be ready to go." And he said, "Trust me, you need to do this."
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Hubble was eventually launched in 1990 and has produced revolutionary discoveries for the last 30 years. Although that stopped a few weeks ago when its 1980s computer that controls and monitors the spacecraft's scientific instruments went offline. Now NASA is searching for a solution. Up until now, it's been able to look back through about 96% of all time. James Webb will see well into that last 4% towards the Big Bang. Hubble studies the universe primarily in optical and ultraviolet wavelengths in close orbit around the Earth. James Webb is over 100 times more powerful. It will be stationed 1.5 million kilometres away, way beyond the Moon, and primarily sees infrared, which can detect objects too cool or faint to see. As light travels, its wavelength becomes longer because the universe is expanding and objects are moving further from us. The longer wavelength means objects look redder. That means galaxies will appear in the infrared by the time their light reaches Earth, known as the Doppler effect. NASA's Infrared Spitzer Space Telescope finished its mission in January 2020 after 16 years. James Webb is about 1,000 times more powerful and will build on Spitzer's discoveries. Now, you were at Cape Canaveral with your wife for the launch of Hubble. How much of a game changer was the telescope at the time?
Absolutely. Well, at the time, unfortunately, Hubble launched with a flaw in its mirror. And so it took a huge effort. the part of NASA and a lot of engineers and scientists to find a way to recover that. And luckily we could go back with the space shuttle, and a new instrument and new capabilities were put on board. But once Hubble was repaired in 1993, it started to see things in the universe that we suspected must be there, but we had no idea of the scale of the galaxies that we saw, of the things that we saw.
Astronauts completed numerous servicing missions to fix it and install new technology. Professor Illingworth co-led a camera effort that went up in 2002. Each new camera enabled scientists to see further back in time and opened our eyes to the more distant mysteries of the universe.
Hubble completely opened up the early universe for us. The discovery of galaxies billions of years ago, back to 12, 13 billion years ago, was a central result of Hubble's capability, and I think an amazing discovery by Hubble. I'd say the other one that Hubble played a major role in was finding planets around other stars and helping to understand them. These are often a mixture of different telescopes play a role in this, but Hubble played a key role in that particular discovery and being able to follow up.
The science and its implications have been mind-blowing, but the extraordinary images Hubble has taken over time have also been breathtaking. Here you see the violent beauty of colliding galaxies, some so dramatic they trigger bursts of star formation. Others highlight the colliding galaxies as they merge into new ones. One of the most recognised and distinctive objects in our skies is the Horsehead Nebula, capturing plumes of gas in the infrared, which is normally obscured by dust. And here is a Hubble portrait of the giant nebula NGC 2014, roughly 165,000 light years away, a turbulent stellar nursery. These glowing stars are 10 times bigger than our Sun. They have short lives of only a few million years compared to the 10 billion years of our Sun. This nebula is part of a vast star-forming region in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. And there are many, many more breathtaking otherworldly images. And astronomers have even greater expectations for what James Webb may reveal. Tell us a little bit about the specifications of James Webb.
So James Webb is about 3 times the size of Hubble. It has an amazing mirror made of beryllium segments, lots of little mirror segments that work together as one. But in the case of James Webb, we need them light, and so they're beryllium, they're coated with gold. And the other reason for beryllium, because we want to work in the infrared, we have to cool the telescope down so it doesn't emit light that would provide a huge background. And in fact, we cool it in space, it will cool down to about minus 220 degrees Celsius, about 45 to 50 degrees above absolute zero, a remarkably cold telescope. So James Webb will be launched and will fly out beyond the moon and will be located about 1.5 million kilometers from the Earth in a sort of a semi-stable region we call L2, which will go around the sun with the Earth, the moon, and James Webb as well following along. Now, to get it cool, one of the key things that we had to do is shield it from sunlight. And so that material always faces the sun, and the telescope can then radiate away out into the darkness and cold of the universe and cool right down to 45 degrees Kelvin.
Which is about minus 228 degrees Celsius. The telescope's 4 instruments, cameras and spectrometers, have detectors that are able to record extremely faint signals. A spectrometer measures the variation of a physical characteristic over a given range. Professor Illingworth has won awards for his work on the most distant galaxies. And now astrophysicist Dr. Renske Smit, who's in the early stages of her career, is fortunate to be part of a team to study them using the James Webb Telescope.
We've been planning a really big survey, maybe the biggest survey that will be undertaken on the telescope in its lifetime. I'll be identifying new galaxies at very early universe. I will be doing distance measurements. So when we measure distance, we know how far back in time we're looking, so we know how close we are to, the very beginning.
Dr. Smit has been recognised for her work to design a new method for finding the most distant galaxies. So what questions do you want answered?
Not one specific question, but I'm very, very curious about how the most pristine sources look like. What, if you look at the sun, it's a much more evolved, it doesn't just consist of helium and hydrogen, but it has more heavy elements like carbon and oxygen and iron. And some of these first stars, they're very pristine, and they have potentially very different properties than the stars that we see in our own Milky Way. And I'm very excited to figure out what that's going to look like.
But will James Webb be able to advance the search for life on other planets? The universe has existed for billions of years and holds just as many secrets, but astronomers and astrophysicists are hopeful the new James Webb Space Telescope could solve some of them. When it launches, it will be operational all year round, and thousands of hours of observation time have been given to selected projects. The study of exoplanets, which is any planetary body outside the solar system, will be given a large amount of time. Sarah Seeger is a tenured professor of physics and planetary science at MIT and has pioneered many research areas in the field of exoplanet atmospheres.
For exoplanets, we have so many questions, and the James Webb will help us answer all of them, not just about having the first capability to search for signs of life on another world, but the James Webb will help resolve a lot of long-standing questions in exoplanets.
And so is there an area of space that you focus on?
Well, it's the whole sky really, but mostly we're trying to focus on the very nearest stars. And even near is incredibly far. Our nearest star system is over 4 light years away. And 1 light year is 6 trillion miles. But the nearer the star, the easier it is to study them.
There are billions of planets we can't see unless they pass in front of their star and Earth. Then we see a dip in the light of that star, but our orbits must be aligned. What will James Webb reveal that Hubble couldn't?
Everything Hubble has done for giant planets, big planets that on the inside are too hot for life. The James Webb has promised to push down to smaller and smaller planets, including some rocky planets that might be able to host life.
Do you believe there's life out there?
I absolutely believe there's life. There are so many planets. We know that small rocky planets are very common, and the ingredients for life, the building blocks of life, are almost everywhere we look with our telescopes. So everything just has to come together in the right way.
The professor's life ambition is to find another Earth.
I invented the main way that we study exoplanet atmospheres today, and it works for a very special set of planets. Planets that go in front of the star, as seen from our viewpoint. Because planets can have all kinds of orbits, but some of them are lined up just so they orbit that star, and they happen to go in front of the star, as seen from our viewpoint. We call them transiting planets. And when a planet goes in front of the star, some of the starlight shines through the atmosphere. And literally, by analyzing which colors make it through and which don't, we can identify gases in the planet atmosphere.
This is called spectroscopy and underlies modern astronomy. A spectrograph splits light or electromagnetic radiation into wavelengths, just as a prism splits light into a rainbow of colours. The atmosphere will help reveal the potential for life on these exoplanets.
If we look at a small rocky planet and look in the atmosphere and see water vapor, that indicates a liquid water ocean. Because unless there's an ocean to keep replenishing water vapor in the atmosphere, there won't be any water oceans. Secondly, we hope to find some gases that don't belong. Like on our planet Earth, oxygen that we all require to breathe. Oxygen is made on Earth by life, by plants and photosynthetic bacteria. And did you know if it weren't for life, our Earth would have virtually no oxygen? Yet our Earth's atmosphere has 20% by volume oxygen. So life on our planet re-engineered the atmosphere and has this giant signal telling, hopefully, other beings in our galaxy that we have life here on Earth.
Although I wouldn't hold your breath for little green men. A recent US government report looked into 144 reported sightings of UFOs since 2004 and concluded there's not enough evidence to prove these objects came from beyond Earth. But one star system that might have some answers is TRAPPIST-1. Situated 45 light years away, it will be getting a lot of attention from James Webb.
TRAPPIST-1 is a very, very small, very cold star. Any smaller and colder, it wouldn't be a star. It wouldn't be able to have high temperatures and pressures on its inside high enough to fuse hydrogen. And TRAPPIST-1 is an incredible star system because it has 7 planets. 7 little planets, almost 7 planets. They all appear to be rocky worlds. And no matter how we slice and dice the system, some of the planets must be the right distance from the star to be the right temperature to host life, actually.
There have been many delays, but soon our astronomers will become some of the privileged ones who will have observational time with the James Webb Space Telescope.
So James Webb will be launched later this year in French Guiana by a French Ariane rocket by the European Space Agency, and it will zoom out beyond the moon, unfurling as it goes. It's an origami structure that fits inside this rocket, and it has to unfurl and assemble into shape as it moves out.
Do we have any idea of when it might launch?
So nobody can give you an exact date. There's sort of a schedule folks are working to, but basically late this year. Maybe it'll be a Christmas present for all of us to see it go up before Christmas.
Have you been frustrated by the delays? You must just want to get started.
Yes, well, I mean, I've been looking forward to this telescope launching basically my entire career. The closer we get to launch, the more excited we really get for it, getting the real data in our hands. And so, at the moment I'm more excited than I am frustrated, really.
It's an amazing time because our whole world is about to change completely. With new eyes on the sky. It's as if you're a person who needs glasses but never had them. And the whole world is blurry. And all of a sudden you put your glasses on and wow, I can see clearly now.